Hello. Today we will discuss class A commutation technique, which is also known as load commutation or self commutation. We have actually described commutation into two basic classification, that is current commutation and second one was voltage commutation. In current commutation we can commutate the SCR if we reduces the current value through it below the level of holding current value. That was our current commutation technique. And if we reverse bias the SCR, then it was voltage commutation technique. Here in this class A commutation technique we are following the current commutation technique, that is we are just reducing the current through the SCR below the level of holding current value. Based upon these current and voltage commutation technique, we have actually classified the various commutation technique, that is class A, class B, class C, class D, class E and class F. We have discussed class F, which was our natural commutation technique. In that commutation technique we actually uses AC source as its source input, but in another commutation technique, that is from class B to class A to class E, we will use DC as its voltage source. Here we are using DC voltage source. In this commutation technique we are using current commutation, that is we have to reduce the current I less than IH value. Here the I is this I flowing through the circuit, so we just have to reduce this I less than holding current value. How it can be done? For this we have to resonate the load. Resonate the load means we just have to include L and C circuit, which is also known as commutative elements. L and C are commutative elements which will resonate the load. Resonate the load means due to these LC elements, due to these commutative elements, an oscillating current is flowing, which is actually decreasing in nature. This is the condition of underdamped circuit. When the circuit is behaving as underdamped circuit, then oscillating current will flow, which is actually decreasing in nature. This current I, which is our oscillating current and decreasing in nature, will flow because of this capacitor in opposite to the direction of current I. So this capital I current will decrease the level of current which is flowing through the SCR. As this I level is decreasing and it start decreasing below the level of holding current, at that instant the SCR will turn off. So in this circuit we actually use a underdamped circuit. How a underdamped circuit can be obtained? By using LC circuit, which allow a resonating current to flow in the opposite to the direction of current I, which is flowing through the thyristor. So this circuit is our underdamped circuit. This type of commutation techniques is used in series inverter circuit. Now we will look around the equation for underdamped circuit. This is an underdamped circuit equation, that is R square upon 2L, that's our whole square, which is less than 1 upon LC. This is the condition for any underdamped circuit. That is, if we want to the circuit to behave as underdamped circuit, then this must satisfy, this equation must satisfy. This is the equation for underdamped circuit. Okay, if we are using this equation, r square whole square greater than LC, this is the equation for any overdamped circuit. And if we are using r square whole square actually is equals to 1 upon LC, this is our critically damped circuit equation. Here we are using underdamped circuit, so this equation will follow. Then the another important thing which we have to consider is the current, that is resonating current, which is actually oscillating current flowing in the circuit. This is the value of the oscillating current, which has a value equal to I is equal to V upon L under root LC sin small t by under root LC. The third important thing is that when the thyristor is turned off, the capacitor voltage will be 2 volt. So here these are the three important actually conditions which we have to satisfy during the circuit is going to turn off. This is the waveform of class A commutation technique. As you can see that this is the current I which is actually flowing through the SCR. Here we have just consider the current flowing from theta 0 omega t 0 is equal to pi. This is actually the phase during which SCR is conducting. We just consider that phase during which the SCR is conducting. In that phase, after that phase at omega t is equal to pi, when we need to commutate the SCR, at this instant we will switch off the DC supply first and then introduce commutative elements, that is commutation circuit, into the circuit in series with the SCR. We will first switch off the DC supply, then introduce commutative circuit. At this omega t is equal to pi, we have used a charge capacitor which has a voltage equals to 2 volt. So here at omega t is equal to pi, the voltage across capacitor will be 2 volt. At this instant only we have just seen that when the thyristor is turned off, the voltage across SCR will be negative. Why negative? Earlier through the SCR the current was flowing in this direction, and when we are using capacitor which is charged to a 2 volt, due to this capacitor the current is actually flowing in the reverse direction. So as the current direction is reverse, the polarity of the SCR will also be reverse, that is negative. So here the polarity of the SCR will be negative at the instant when the SCR will turn off. So these are the waveform. This is the current I which was actually flowing when SCR was conducting. This is the voltage across the capacitor which is equals to 2 volt. 2 volt when we need to turn off the SCR, and this is actually the gate pulse when we actually triggered the SCR. It has a gate pulse at omega t is equals to 0. And then last, the voltage across the SCR when it will turn off. The voltage across the SCR when it is conducting, we will assume that it will be 0. Okay, but when it will turn off, the voltage across SCR will be negative.